Unit number 4, the access control. We started last class, and even though we are going to just have a small briefing on that, it is a context of award the resources to different users accordingly. We are going to prevent the use of resources in an unauthorized manner. So we are going to grant privileges to different users accordingly upon their recognition. And the context of recognition here is the authentication. Means an administrator and a normal user would be authenticated using the same scenario, might be. Yet, privileges inside the system would be completely different, and this is the context of the access control. So we are awarding access to resources. We are making subjects reach resources and objects differently, each with his own capabilities. The access control in an environment, in a system, is a centralized component. It's utility to control the access to resources. It's a centralized scenario, system, environment, entity. It controls all. Subjects, access and resources. Subjects, access and objects. A graph that illustrates the view describing the concept of access control. And here actually the access control, it is the implementation of security policies that specifies the reach of resources. Whomever is able to reach the specific resource, targeted resources, things like that. We see that the user is the front end of the full environment. Authentication mechanism actually would be set to filter who is able to access the system, who is not. And after the administrator will play the role of controlling the access to resources. This is the centralized scenario here. Everybody inside the system would be controlled to be given or to be denied from accessing the resources. So filter number 1 to authenticate, to let in the system. And the filter number 2 was to award access to resources. This is the privileged view. So users will be actually filtered here inside the system. Even you are authenticated, but still you will not be awarded access to all resources. For groups via which we award access control, we set up the control actually on access. We see them actually one by one: dark mark, back and back, discretionary access control, mandatory access control, all based and rule based.
مستر لو سمحت.
Requirements.
مستر لو سمحت.
Yes, tell me.
مستر الصوت معنا واقف يتردد من عندك.
Are you able to hear me better now? Shall I continue? Let me, is the voice okay? The requirements for the access control, they actually, some of the features that you have to fulfill in order to talk about the access control before setting up the 4 rules here, the policies, the dark mark, back and back. We have to talk about requirements, which are features, specificities. It is a common sense. We have to set them up before talking about any model, any policy that we're going to follow. Those requirements, you have to talk about actually an authentication mechanism. Remember, the access control is something to happen inside the system. It's not outside. You have to be authenticated already. So you have to be authenticated. This is for a first step. Good. Group of features to regulate the access means we have to have policies, but here actually to access the system by everybody, or to access the resources by everybody. Yeah, there have to be actually some rules to access the resources. The control of privileges has to be set, means resource has to be from the beginning restricted access. They have to be actually set with no access to everybody. The minimum access has to be given to just make the system run. And then after we talk about privileges based on the session, or session-wise actually based on the users. Least privilege. These from the beginning of the generation of the system. Everybody actually would be given a minimum authorization, and then after we will be segregate the roles and segregate the resources upon the sessions, and those sessions, they are related to users. And here the sessions would push us to segregate the rules and segregate the roles. Whomever is inside the system would be awarded an action to do or activity to do, which is a duty. So we have to separate the duties from the beginning. This is a requirement. It is not mandatory to be talk about the access control. It is an initial step to do. Subdivide actually the roles among users. Now we talk about the policies. Clearly talking here. There have to be policies to make the business run. Means the availability of services and let's say yes, resources to end users. There have to be rules, which are policies, and these the company politics to manage that. Yes, and here we talk about the availability, non-availability, open and close policies. Yes. Beside of that, the administrators have to have actually specific extra features of control. Mainly, we talk about to add and delete and edit either services or users or anything inside the system. They are administrators, no? They can add, delete, and modify a user profile, an object profile, a product, whatever the service is. They have to have full control, since they are administrators. So those are requirements to start building up an access control to resource. The first model, the first time, is the DAC, but access control elements. Yeah, we presented that in the prior classes. Elements constituting the access control environment are subject as a user, object as a resource, and access right, which is the role to do.
أستاذ مناد ماشي صوت.
نعم just I was actually receiving a guest here. So let's continue. The access control to be given now, there are types, and the first one is the DAC, discretionary access control. Remember that the access control means we are going to give capability of reading, writing, editing, or all of them to a subject. And those actions actually they would be applied on an object. The subject means a user. Yeah, simply. An object means a resource, a file, a table, a page, whatever. It's a function, it's a procedure, something like that. The DAC, or discretionary access control, is a context via which we award access to resources to users based on the use of a matrix. And the matrix has to be actually a sparse matrix. Sparse matrix means there are actually users that would be actually awarded a full access to resource, full access and full control. And others that would be actually having a partial access and control on a resource. Others that would not have any access to any resource. Depends. This we say, because of this we say it's a sparse matrix. The draw of discretionary access control to resources, it is the base of implementing a matrix, and it is a sparse matrix to draw a relationship in between the subjects and the objects. List of subjects that will be actually having access to objects, in plural usually, and there will be actually roles and tasks to do, subject to object. It is said an access entry or an access write from a subject to an object. Good. Yes. This is an example of a matrix where we see three subjects, user number 1, user number 2, user number 3, and we have resources. They are files here, but whatever the resource is, we are controlling. So each user is given a group of functions to do, his capabilities. Those are the rights that he would do on those resources. Let's read. User number 1 is the owner of the file 1. User number 1 is having the capability to read from file number 1. User number 1 can write on the file number 1. User number 1 cannot even see the file number 2. User number 1 he's the owner, can read and can write on file number 2, number 3. User number 1 cannot even see the file number 4. And the same thing actually you can apply on this list of rights for the user number 2 and to the same resource. The same applies on this user number 3 and the resources also. So it is a context, and here, see this empty block here, they implies to us, they make us understand that this user cannot do anything for this resource. This user cannot do anything for this resource, even to see, even to visualize. He cannot, because he cannot read. See, the same thing here for this user. For this user, he cannot do anything for this resource. Even he cannot read, he cannot display. Access matrix. These want to be implemented to the system. Reading this thing actually, it is a context of data structure view. We have pointer to point. from the user until the end. From user number one, what to do on the resource. Then after, the user number two, what to do on the resource. And then after, the link goes to user number three, what he can do. Use a linked list. So for the file number one, user number one can do those functions. Then user number two can do those functions on the same resource. Then the user number three can do those functions on the same resource, which is the file number one. File number two, user two, not one, B, because resource two, we have user two and user three. They have access and they can do things on that. But the user number one cannot do anything. So user file two, user two and user three. File three we have user one and user two. Three does not have anything. So file three, user one, user two. That's it, and we finish here. It's a view drawn using the data structure architecture. From the other side, here actually we talk about from the file and there is the function, the rights given to users. Now we read from the users. User number one, what he can do. He can do things on resource number one, and he can do things on resource number two, but 2 and 4, he cannot do anything. 1 and 3. So user number one, on file one, those are the rights. Then on file number 3, those are the rights. That's it. User number 2, he have rights on all. Resource 1, resource 2, resource 3, and resource 4. Let's read that. User 2, on resource number 1, is the right. Then on resource number 2, those are the rights. Then resource number 3, those are the rights. Then resource number 4, those are the rights. Yes, so you really like that. Either the access for files on access for files, that's it. Or the capabilities of users. Two readers, two different readers. We do not have to do them both because both of them, they give the same final result. Resources and access on files or resources. Whatever. Good. The same reading here actually we're making it more readable and more understandable to us as users. User A, user A, user A, user A, user A. Those are the users. The rights for each user. See those rights we are drawn. And the resources. What he can do. This user in number 1. How many rights he have? 3 and 3. 6. So we have 6 rights to have. 1, 2, 3, 4, 5, 6. So those are the 6 entries of this user. User number 2. User number 2, B. 1, 2, 3, 4, 5, 6. He have also 6 functions, 6 rights, but on 4 different resources. 6 rights on 4 different resources. Let's see. User number 2 from here starts 1, 2, 3, 4, 5, 6. Here's the user number 2. Exactly. 6 entries. On how many resources? Resource number 1. resource number 2, number 2, number 2, resource number 3, and resource number 4. And the same apply for the others. Any questions here, please? Are you able to draw this relationship? Okay, that's great. Since no questions raised, means it's clear. The access matrix, it is not the unique model here displayed to us. It is not with one unique model that we can see here. We see an extended model here, where actually the subjects, sorry, where the objects, they are actually drawn with more details, because objects that might be processes or services, and also they can be actually controlled, not controlled, but displayed as subjects. Means the objects, they might be as also subjects. I give you the example. On EduWave in our system inside the University of Missouri, me as an instructor, I can see your profiles, I can see your grades. I might have some actions to do on your profile. Display, hide, upload mark, modify mark, something like that. So you are a subject. I am a subject. But when I control your profile, you are considered as an object to me as a subject, because you have less right, and I am having higher right. I'm considered as an administrator. I'm controlling you. So I'm having a task on your profile, on your role. So you might be seen as an object. Thus, we are talking about an extended sparse matrix. In addition to that, the processes means what the computer can do, and what the services they are using as resources. Not only files what users has to use, but the system has to use also based on a session can be controlled. It can be set as an object. Extended matrix. Any questions? Great. The access control, actually, it is a system intervention. Remember when we said that it is a centralized. Great. No, Khadija, thank you. Since we said that the system, the access control is centralized, so it is a system intervention. All what we are going to set as access control, as group of rules to control everybody here, it is inside the system only. Whatever the task to do. Examples we saw the read, the write, and the execute. But whatever the functionality to do, it is inside the system. Well, then we are going to read, write, and execute. We're going to award of a task of starting and closing, beginning and ending a process. This is actually a right to be given. Remember that a subject is somebody that acts. It's not a body person only. An antivirus might be playing the role of a subject. A firewall might be playing the role of a subject. Yes, so a system might be playing the role of a subject. When he wakes up, an antivirus or an intrusion detection system. So this is something to be controlled. Not everybody can wake up a process or can access a process. Not everybody. Then actually me as an instructor, I can give you one of the students, or let's say technical people, the administrative technical people, they might give extra features or extra functionalities to specific users. So they can grant or delete functions to roles to different subjects. Those functionalities, they have to give access to different resources accordingly, and they are mainly whatever they are inside the system, centralized. This reading here, we may read it differently also. Yeah, actually, we have a rule and we have an operation to do. Any example I'm going to give actually here? Let me just simply speaking, an access control, it is built on a rule to do an action, and it has to be done after an authorization. Remember that the authorization I asked you last class, what is the sequential view authorization authentication? The authorization in the first place. So to authorize the reaching of a resource in order to do an action, to finalize an operation, authorization takes place in first view, based on a rule, or based on a rule. So to authorize or to do an operation, to finalize an operation, there have to be a rule to do. Yes. It is a matter of reading only. There is nothing to be obscure to you. It means I believe that it is exactly summarizing what we were saying about the DAC, discretionary access control. Just the last point I'm going to explain. The resource to be controlled. Remember that we can talk about processes to control, and the process, they are seen from different layers. The kernel mode here actually that the operating system might act within, or tasks, let's say processes might run at the level of the kernel. Remember the kernel, that it is a layer that comes in between the OS and the hardware. Yes, so this might be actually controlled, and the access control, the DAC here might be playing a role here to, let's say, permit or to deny the, yes, to grant access or not at this level. The kernel is a layer below the operating system and on top of the hardware, who is able to perform any action or any operation on this level might be controlled. Yeah, this is an access control to be happening here also. Yeah, I'm comparing those two statements here. Here, when we say in user mode, we are just fine run the system normally. There might be actually instructions given permission to users to execute, and instructions that they are forbidden to be executed by users. Commands to open software, to close software, like the antivirus, for example, or insecurity applies. Yeah, they might be controlled, those tasks. In kernel mode also, the tasks on memory actually might be controlled even. Not only operation-based, but even the areas in memory, the hardware itself, might be controlled. Yeah, everything in Unix, remember, as per the rights we defined in unit number 3, the authentication, read, write, execute. Actually, everything in Unix is a file, is considered to be a file. Any function you do, any activity you do in a Unix environment is considered to be a file. And regarding the access control, actually everything is controlled within a group of files nominated index nodes, inodes. They would be actually loaded at the load up and the boot of the operating system. When the operating system, the Unix-based operating system is booted, those inodes would be actually loaded to recognize the yes, to set up at the beginning the access control to all the resources that your operating system is controlling, actually is operating on. At the end of the day, an inode it's a file. Inode is a file. Inodes, files. This inode has the resources information. And those informations, they would be actually given the access or the denial to the specific resource. Yes, they might allow, they might deny. Who? Those inodes. An inode, it's an access control to a resource. Inodes are access controls to resources, different resources. These are files. Those are files. In general, in plural or in singular. Let's talk in singular. In singular, and I notice a file that has some specificities to specify either yes, you are awarded access to a resource, or no, you are not. The EF files available in your environment, no more, no less. Remember that they are actually to be loaded to the let's say volatile memory at the boot of your operating system. Yeah, and they might be see actually with hierarchical view in the sense of user and sub-user, group and subgroup with users. So we can see different levels, drawing the link in between the inodes. Yeah. So in a Unix environment, every object, I repeat, has to give an access to every subject, like so, to read, to write, or to execute. Read, write, execute to every object. Sorry, yes, every object gives the write, the read, write, the write, and the execute, write to every subject. The subjects are three: either a normal user, or a group, or anything else like processes or software, antivirus, firewall, something. In this example here, a resource, a file, something, the bytes given are like so. To the users, they are capable to read and write only. they cannot execute, minus. Two groups can read only. They cannot write and cannot execute. Groups means, let's say, students, instructors, administrators. So we classify them by groups. Others, they can do nothing. Even read no, display no. They cannot see this resource. So in a Unix environment, a resource has to be controlled within 3 blocks based on the subjects, because the subjects, they are seen in three groups. Let's say 3 blocks: user, normal user, and most of the users, the administrators. Remember, a group, yeah, we classify the list of students, the list of customers, the list of technicians, managerial staff, groups, or any other. Mainly we talk about the process and the services on the environment. And each of those subjects has to be given one of the 3 rights or all of them. So from the 3 rights, they read, the write, and they execute. The system will recognize them with 3 letters: RWX. Either all of them or part of them. In addition to that, we have we specify the sticky bit, which is actually one binary bit that specifies that a specific subject has the capability or has a higher level, is awarded a higher privilege on a given resource. Yes or no? If the one, yes, or no, he's not awarded this list of privileges. So the sticky bit, it is one indicator on a resource to indicate that the concerned subject is awarded higher privilege or not. Higher privilege means he can do such tasks: to rename, to move, to delete. Any questions, please? If you hear your name, please just say yes. Say yes. I'm going to take the attendance.